This video is a review on figures in the coordinate plane. So, I'm a little lower, I've got a different chair, so I'll see if I can do this. This is to help people who struggled with the coordinate plane test or people who missed that lesson so they can try to understand what the important aspects were of that lesson. So we had two different things that were going on. First of all, we had to know about the figures being involved. So the properties of the triangles or the properties of the quadrilaterals that we were looking at. So that's one area that we had to know. Scalene, isosceles, equilateral, what do those things mean and how do I find them? The opposite sides parallel, the opposite sides congruent, the midpoints bisect, and the right angles. Those would tell us if something's a parallelogram or a rectangle or a square. But then we also had to know about the coordinate plane. So we had to know how to use things like slope and distance and midpoint to find out these things. So this is where that knowledge comes together. Now what I suggest that you do, and this will be part of your requirement to retake the test, is that you make flashcards. So I made flashcards and I started with things like properties of parallelograms. And then on the back I wrote down what were the properties of parallelograms from the notes. Okay? Properties of rectangles, what makes them special. Properties of a rhombus, a trapezoid, and a kite. But then after I thought about the properties, I also went back to how would I find the length of a side? And on the back I did an example. Oh, I'm going to use a squared plus b squared equals c squared, and it's going to look like this, and here's how I'm going to find it. How would I prove that diagonals bisect each other? I turned that over and I said, oh, I would look for the diagonals, I'd sketch them in, and I'd see if they have the same midpoint. And here's the midpoint formula to show me how to find the midpoint. How would I prove that I had right angles for, let's say, a rectangle or a square? Well, I would remind myself that they're going to have opposite reciprocal slopes. So I'm going to use y2 minus y1 over x2 minus x1. And I have a picture showing me how to do it. Parallel lines. Oh, I'm going to know they have the same slope. So I'm going to do y2 minus y1 over x2 minus x1 for each one. You see that? So I want you to go through and make yourself cards that summarize these things that we go through, and you'll show me those when you're ready to take your retake of your test. Okay? So that's an important aspect, is that you're going to do the flashcards. The other thing that's important is on your retake piece of paper that you got in class, there's a big blank section on the bottom half of the page, and on that you're going to go over the problems that we do. You're going to try to show those there on that paper. That's how I'll know that you actually are prepared to retake the test and that you've learned something from this lesson. Okay, so the areas that people are struggling with is, how do I actually classify that figure? Where do I even start? What do I do? So I want to make sure you see. The first thing we're going to do if they don't give you a graph is graph it, so you can look at it and see what's going on. The second thing is you're going to use your normal instinct to say, what does it look like? Well, it looks like a rectangle. Okay, that's my starting place. How can I prove it's a rectangle? Well, I'm going to use slope, and I'm going to use distance, and I'm going to use midpoint, because those things will tell me whether I have the attributes of a rectangle. Once I decide what it looks like, I have to know those properties. I have to know, oh, all four angles are right angles, so I'm going to check the slope, and the slope is going to be opposite reciprocals. Otherwise, even if it looks like a rectangle, if I don't have opposite reciprocal slopes, it's not a rectangle. That's what I need you to understand. We start with what our eyes tell us, but then we have to use the math to prove that it's true. Why don't we do a couple of examples? So, number one, classify this triangle. Now this is where I'm going to say either it's all three sides are the same, equilateral, two sides are the same, isosceles, or no sides are the same, scalene. So, I'm going to be looking only at side lengths. I'm not even going to be looking at anything else for that triangle. So, first thing I'm going to think about is using my a squared plus b squared equals c squared. So, I go like this. From here to here it goes over 1, 2, okay? So a squared is 2 squared. This goes up 1, 2, 3, 4. Okay, so for that first side I have 2 squared plus 4 squared equals c squared. Now I'm going to come over to another side, and it goes over 1, 2, 3, 4. And it goes up 1, 2. For the last side, I'm going to go, it goes up 1, 2. And it goes over 1, 2, 3, 4, 5, 6. Okay? So I get a funny looking figure where I've moved my pen along there to see how long each length was. But let's take a look at what we actually got. We got 2 squared plus 4 squared. 2 squared is 4. 4 squared is 16. So that equals 20. That doesn't mean the side is 20. It means c squared equals 20. Okay? So I know that c equals the square root of 20. But take a look here. 4 squared here is 16. And 2 squared is 4. That second side is exactly the same. Okay? The third side, if you look at this, I don't actually need to do the math. Because if these were 2 squared plus 4 squared, and this one's 2 squared plus 6 squared, that can't be the same. But what I do have is 2 sides that are the same. So this one would be qualified as an isosceles. Okay? Does that make sense to you? Let's look at the second one. Whoops, got to move myself over or move the board over, one of the two. Here we go. Okay, so what I'm trying to figure out here is what kind of shape this quadrilateral is. Okay? So I've already done my little checking across here, but I've decided to use slopes for this shape. Not because I have to, because nobody tells you what you have to use. So I could use either opposite sides are parallel or opposite sides are congruent. Either one of those would tell me whether I have a parallelogram here. I've chosen to do opposite sides are parallel simply because last time we used the distance, and I want to give you exposure to a couple of different tools, then you can choose which one to use. So slope would tell me that if the opposite sides have the same slope, then I know they're parallel lines. So let's take a look. First thing I did was how many do I go up here? 1, 2. And how many do I go over? 1, 2, 3. So the slope of this line right here is 2 over 3. Now I'm going to check the opposite side because that's the one that should have the same exact slope. And I look here and it went up 1, 2. And it went over 1, 2, 3. So all that's really important with slope is making sure that you remember to put your up and down goes on top. Your side to side goes on the bottom. That's our rise over run. Okay, so far these two are parallel, so that's good. But I need to check the other two sides because they have to be parallel also. So I come here and I see it goes 1, 2, 3 over, and then 1, 2, 3 down. So I get negative 3 over 3, which comes to negative 1. That's the slope of that side. Checking this one, it goes down 1, 2, 3, negative 3, and then over 1, 2, 3. The same number, negative 1. So these two sides are also parallel. So I know that yes, this is a parallelogram. Now, the only trick with this is it might be a more specific kind of parallelogram. It might be a rectangle or a square or a rhombus. So I have to check for those. Now, what makes a rectangle and a square special is that they have right angles. So if I check this and see if it's a right angle, I'll be able to tell if it's a rectangle or a square. So the way I can check for right angles is they should have opposite reciprocal slopes. So if I took this slope and turned it upside down and made it negative, that would be the perpendicular or the right angle slope. But look what I really got. I didn't get negative 3 over 2 for that other slope. I got negative 3 over 3. So these are not a rectangle or square. I didn't get a right angle because I didn't get a reciprocal. Okay, so the answer there is no. So I need to just check now rhombus. So I think to myself, what makes a rhombus special? Oh, it has all 4 sides the same length. So let's check our side lengths real quick. What's cool about this slope is that up and over, one of those is your A for A squared, and the other one is your B for B squared, and it doesn't matter which is which. So in this one, when I went up 2, that's 2 squared, and I went over 3, that's 3 squared. So this side here is 2 squared plus 3 squared. Okay? That means for this one, when I went down 3, I got 3 squared, and when I went over 3, 3 squared. Well, 2 squared plus 3 squared does not equal 3 squared plus 3 squared. So these two are not congruent sides, so I don't have a rhombus. So this would be my final answer. So step 1, when you're asked about the quadrilaterals, you want to check and see if it's a parallelogram, unless you obviously see right angles. If you see right angles, you can real quick check and see if it's a rectangle and go straight there. But in this one, I didn't think I had a rectangle because they didn't look like right angles. I still did the math to check, but they didn't look like right angles. Okay? So, let's take a look at a couple more that are similar to that. All right, well, let's pull this over. So in this case, we are given 4 ordered pairs, and we need to draw them in. So I'm going to draw these in. I've drawn in G, and H, and I is -4, -5, and J is -7, -2. So double check those points. Make sure that you've filled in your points properly. Let me double check here. I have -4, +4, -1, -2, -4, -5, and -7, -2. Okay? And they connect the dots here in order. Womp, 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 womp. Okay. I don't know if I've got anything in that. So what I should do is, it could be a kite or it could be a trapezoid, but I'm pretty sure it's not a parallelogram. Do you see that? Parallelogram, they would have the same. So what I'm going to do is I'm going to check the kite. Now what's true about a kite is that its diagonals are perpendicular. Now if I don't know its diagonals are perpendicular, then I just got to guess, and I'm not going to be able to answer the part about justify your reason. But this is the diagonal this way, and this is diagonal this way, and you see how, because they're on the actual axis, I can see without doing any math that those are perpendicular. So this one is a kite. Okay? When you get a strange shape and it doesn't look like a parallelogram, don't just blow it off as nothing. Double check and kind of turn it from different angles and see if it looks like it might be something else. Okay, now this last one is something you better pay close attention to. It looks like a kite, but the instructions on this one don't say to classify this figure. It says classify the figure formed by the midpoints. You've got to read those instructions. That means I need to find the midpoint of each side, connect them, and then see what that shape is. Okay? How do I find the midpoint? Sometimes you can see it. See how this one is right here? There's a midpoint, there's a midpoint, there's a midpoint, and there's a midpoint. And I'm drawing them very crooked lines. Look at that. Okay. But I can see something. I can see because these are right on the grid lines. These are 90-degree angles. And I can see that the figure formed there is a rectangle. Can you see that? But let's review how to find the midpoint in case they're not nice enough to put it right on the spot for you. First thing I would do is I would come over here. This is -2, 0. And this one is 0, 1, 2, 3, 4. So to find the midpoint, I first look just at the x's. And I add them together. And divide by 2. Okay? So -2 plus 0 is -2. Divided by 2 is -1. Now I just look at the y's. 0 plus 4 divided by 2 is 4 divided by 2, which is 2. So that's how I know that's what the midpoint is. Sometimes they won't be clear or there'll be a decimal. And the way you find the middle of anything is you add the two ends together and then divide what you got in 2. That's how we find the middle of everything. So if I look here, I can see that -1, 2 is in fact the midpoint there. So that's just a quick review to remind you. But if you can see it, I can see that's the middle and I can see that's the middle, then go ahead and just draw it in. Trust yourself and avoid doing more math work if you don't have to. But please read the instructions. If it asks you about those midpoints, don't just grab this first one and say, oh, that's a kite. Yeah, of course it's a kite, duh, but that's not what they asked you, okay? So in this case, the answer would be a rectangle. I'm stuck together. All right, the last thing I want to make sure that you do is think about the relationships with this graphic organizer. Don't know if you can see it very well. Okay, if this entire board represented all quadrilaterals, that means any four-sided shape, then as a subsection, I have all parallelograms inside this strange shape. Everything in here is a parallelogram. Now, as a subsection of parallelograms, I have rectangles, I have a rhombus, and in between is squares because it shares attributes of both a rectangle and a rhombus. But outside, trapezoids and kites are not in the same because they're not parallelograms, but they are quadrilaterals. So I want you to think about those relationships because you will have to provide for me a graphic organizer with the relationships when you take your test. Okay.